Good morning, everyone. Welcome to day 9 of day 28 of Technology Careers with Anita B. Today, we are going to talk about hardware engineering. It's somewhat a rare topic, and I know that we don't see a lot of women in hardware engineering. But today, we have a very special speaker, Jyothy. Would you like to start the presentation by giving everyone an introduction of yourself?
Sure. Thank you for the welcome, Jane. I'm Jyothy. I'm currently working with Global Foundries as a design verification engineer. I started off my career as a hardware design engineer with IBM about 6 years ago. So those of you who do not know who a design verification engineer is and the difference between a verification engineer and a design engineer, I would say huge difference. So that was a change that I made along the path, and I really enjoyed this career, this job. And as Jane said, there are not many women who do this. Almost every meeting that I go to, I'm the only woman there, which is still kind of a big deal, right? And that representation is very important. We definitely want more and more women here in the hardware engineering. And I would say there are even fewer women who actually go forward with this career. Like most of them kind of leave it once after they become the leads or kind of take the management path after a while. So there are even fewer women who go all the way up to like architects and CTO levels. And we definitely need more representation there. Thank you so much for organizing this. This is a great venture. This is a great idea because when I attend, I've attended GHC in past and always had this question like, what do you do? Well, I'm into hardware, and it's kind of hard to explain and how I really come under the wide arena of computer science. So this is a great venture. So without further ado, I would like to just get started. Today's session, I'm kind of thinking of doing like a question and answer session. Before that, I'll just give a brief overview about the different kinds of hardware engineers that are out there and how a day in my life looks like. So here we go. So as I said, there are all flavors of hardware engineers. I have a typo right there staring at me, but sorry about that. So all kinds of hardware engineers out there. I would start with the architects, which are common, just like software field, we have architects too. So anybody who works on the hardware side of a product can be considered as a hardware engineer. And it starts with architects. Of course, the customers come with all kinds of crazy requirements saying they want this magical product, and architects kind of make that happen. They look into the components, what needs to go in, what needs to be added, and kind of just architect the product and hand it over to the design engineers. Now, hardware design engineers are the ones who actually code that vision from architects. They code it in either Verilog or VHDL, which are both hardware description languages, which what it means is like you can convert that language into the actual circuits. So hardware design engineers do that job. From hardware design engineers, the code goes to the hardware design verification engineers, which is where I come. So my field is kind of a bridge between a software and a hardware. We are test engineers for hardware designers, which means we take their Verilog code, we test it in our environment. We have different kinds of languages and methodologies to test it. We could be using C, Python, and there is always the suite system Verilog, which is what I'm used to and I'm biased to. But that's what it is. And from us, so the next category that I'm going to say is mostly like analog engineers. So when we think about a product, there is the digital side of things where, the bits and zeros and kind of making things happen like design-wise. There is also the analog side of it, like as to what voltage it should be, how much space do we have, what are the resistances like, and can we really make this happen, things like those. And those are answered by the other two kinds of engineers that I've mentioned there. So to be on the safe side, let me say this, these are not the only kinds of hardware engineers out there, but these are the ones that I'm most familiar familiar with, and that's why I chose to speak about them. So we have the physical design engineers who actually look into the flooring and kind of see how to really place that product onto a circuit and how it would really look like on the die, things like that. And we have the signal integrity engineer who actually look at just what it means, the signal integrity. I'm not going to go into detail about that because I am not an expert there. As I said, I'm a hardware design verification engineer, and my job is to take the design that somebody has coded in Verilog and kind of simulate, try to make sure that whatever the architect had envisioned is being achieved by the designer himself with this code. So what does my day look like? Well, my day looks mostly like looking at the black screen you see on the left, which is a waveform window. We kind of simulate the designs, run a test, and it generates these waves. We have different tools that generate these waves. And my job is literally to look at those waves, look at ones and zeros, and try to make sure those things are in the right place. So my job is either looking at the black screen there or working in a lab. My current job at Global Foundries, although I do not work in a lab, I have done that in the past. So that could also come under a design test engineer's arena, actually taking a design, taking it to the lab, kind of running it on the circuits and trying to see. Even then, we would be just looking at the logs. So it's a lot of going through the log file that was created, trying to make sense, looking at these waveforms, trying to see, are all signals okay? You see that red signal right there on the waveform window on the left. See, that's a problem. That means like something is not being driven, or the data is not, there is nothing there on that signal. So my job is to look for those kind of signals to see where are the reds, where are they highlighted, or are they in right places, or you see that small step over here, trying to make sure that step is happening at the right time. So that's my job. And we do have other things too, like just like software engineers, we do run regressions over our test cases. We have regression suits and all that, but it's mostly debugging. So what is fun about my job? What is fun about my job is like the joy of it comes from seeing a product go from conception all the way out to the production. Like, I think the joy will be even more if it's a consumer product, knowing that something that you worked on is out there being used by everyone. And that gives me a lot of joy. Now, the innovative part is like every time we have a new product, there is something new coming in. With all these new technologies, with AI and machine learning, we have newer and newer components come in. So every time there's a new product, there is something new that I have to learn, or something new that I've never heard of before. And that is really, really exciting. Now, one of the primary differences between a software engineer and a hardware engineer, I feel, is a software engineer has to have the ability to kind of adapt to different technologies, to learn different languages fairly quickly, and kind of be able to move from platform to platform. Well, with hardware engineer, we're kind of at an advantage that we don't have too many languages. So we have had VHDL from the beginning of time, and Verilog came along, and then there is System Verilog. That is pretty much it with respect to the hardware description languages. But it doesn't mean there isn't innovation happening. There is a lot of constructs that are being added to System Verilog. These languages are being developed currently as well. So there are new constructs and new things coming up in that language, but we don't have to really, as a design verification engineer, knowing System Verilog is good enough for me. I don't really have to have that wider, and I don't adapt to different languages very often, but I have to have deep knowledge in System Verilog. So the learning curve, or the knowledge, I would say, for a software engineer would look more like a V-shaped, whereas for a hardware engineer would be more like a T. You need to have an awareness of other things, but you really need to know your language, like Verilog and System Verilog. And another difference between a hardware and a software engineer is like a seasoned hardware engineer is valued like anything, because a good so for example, a hardware design engineer, a good hardware design engineer would know as they are coding as to like how this code is going to really translate into onto a circuit, like thinking about it from a delay point of view, thinking, oh, how many registers am I adding to this path, like how is the circuit really going to lay out. So a seasoned engineer would know that, and that is highly valued. And the same goes with the design verification engineer. If you have done this quite a few times, when you see symptoms, you kind of know where it could be wrong. But hardware bugs are really hard to track because it could be anywhere. It just, I mean, I think it's the case with software as well. But with hardware, we have, so as a good like with hardware, it could be with the, with what is coming in, we look at the inputs, we look at the outputs, and try to figure out what went wrong at a particular point. So the way we work is we have a set of inputs that is going into the product, like say we're trying to click on something and trying to retrieve a particular data. So there is, from a product point of view, from a hardware point of view, I know when there is that thing, what comes in when you click on something, and when you're requesting a particular data, what are the signals that are coming in, and I know what needs to come out. And based off that, we kind of compare between, is what is coming in reasonable, is the inputs, are the inputs looking okay, and are the outputs looking okay. If not, I need to go deeper into the circuit and kind of see. So this is all done from a simulation point of view, and that is why I said earlier that the design verification engineer's job is kind of between hardware and software, because I need to know the circuit really well enough to really understand what the design is, but also have the ability to like look through the code deep inside and try to figure out what went wrong. Oh, I'm expecting, a signal to go high at one point, and I'm expecting its output to be low or high, and kind of decode from that as to what might have gone wrong there. So that's what is really happening in a DV engineer's life. So that's all I really have about an intro. I was thinking of going about it by question and answer. I'm sure there are reasons why you all are here listening to me, and I would love to answer those questions if you have any.
Oh, okay, so Jyothy, I have a question. So you mentioned that you need to know a little bit about AI. So how much AI do you need to know before you have to work on hardware side of things?
Not really knowing the technology, it's knowing the product itself. So when you say AI, it's going to be an AI based product, right? And what goes into that product is the important thing. Like, what are the different components that go in? And you need to know about those. Like, are you asking this question from a switching point of view? Like, are you thinking about going from software to hardware, or switching from something else into a career like this?
That is actually my other question too, is, do you often see software engineers switching into hardware engineering?
Not very often, but the switch isn't too difficult. And I would say the easiest way would be to start with the design verification engineers. Like, because as I said, it is a bridge between software and hardware, and having that software background helps quite a bit with design verification engineers, because our languages are also object oriented. So the coding part would be much easier, but having the understanding, that takes time. That takes a little bit of time. And I have seen people switch back and forth, but not very often, though, to be very honest.
Right, right. I feel like you tend to, you're telling us that you know more on the software side of things to also help you to do your job a little bit more smoother. Is that a true assumption?
It is, yes. This hardware design engineer has to know, like 50-50, has to know software and a little bit of hardware.
Okay, that's pretty impressive because it's not easy to learn the software programming languages, especially when there are so many different formats.
So we don't have a lot of software languages that we use in hardware testing. It's primarily C, C++, Python, and then we have the hardware language itself, which is the system Verilog language.
I see. And you had mentioned that right now you're not working in a consumer product.
No, I'm not working on a consumer product right now.
How is it different from, like, say, a medical product versus a consumer product when you're working in hardware engineering?
So that's the thing. That's the fun part. The products from a hardware perspective look very similar as to what are our interfaces, what are our inputs, output ports. These, from a pure product point of view, they are going to be very similar. Like you have the same things. If you're trying to build a medical equipment, if it's like it has to have those input ports and output ports, and those specs are going to be very, very similar, I would say.
So
I mean, you would definitely have IPs that are very much oriented with that product, but like deep inside, you can, once you get into the hardware realm, you can go from different kinds of product. You can be working on a medical product, and you could totally switch job into another kind of technology company as well. That's what I'm saying. You could move to a different kind of product because deep down we use similar kind of modules.
I see. So basically, if you understand the requirement, you build based on the demand of, how you
Yeah.
want the product to function.
Yes, yes, yes. So yeah, that's what architects do. They look at that requirement and see how what are we doing. So for example, say something like a memory controller. A memory controller is where, as it says, it just so there is, say, a huge memory sitting somewhere for cloud purpose or whatever, and the memory controller would basically control all the transfers going in and out of that memory array, right? So a hardware product could be the controller itself, like really looking at the requests, the right requests that are coming in, or the data to be written, or data to be read out, and kind of like managing the traffic with respect to that. All right. And different kinds of product. It could be like a 5G receiver. Now, how does a memory controller really relate to a 5G receiver? Well, when you look at it from a product point of view, the way it's all about some requests are coming in, it is being managed somewhere, and it is going into somewhere to do something. So that's what is basically happening, and the ports for it could be the same. Like, how are we connecting this thing? Like, do we have PCIe there? Do we have USB ports there? What are the different kinds of ports? Depending on these kind of ports, how's the data coming in? Say we have a USB, and the request is coming through USB. Now, USB is a standard by itself. So whether it's a controller product, whether it's like a receiver product, 5G receiver product, the way, if it's a USB at the connection, the way data is going to come in is going to be identical. What it does inside, what is the purpose of the product itself would be different. That's all.
Okay, that's very interesting. Thank you so much for explaining that in detail. Okay, well, thank you so much for joining us for today's talk. And I see a few comments saying, glad to finally see Hardware Engineering Tech Talk. And Nina, I want to say it's very nice to hear from you, Jyothy. Thank you.
Thank you so much. Thank you so much for this opportunity. Thank you so much for your time.
Yeah, thank you. We really appreciate you speaking for us.